Dita, have you made me presenter? Because I only see the two of us.
Yes, you are a presenter now, and it's start already.
I can't see my presentation. Okay, now it works. Okay, it's right on time. Welcome everybody to the EnOcean Alliance quarterly webinar. Thank you all for taking your valuable time to be with us today. So today I'll be giving you a very short overview of the high-level opportunities we have with our great technology. And then I'm very honored to have our guest speaker today, David Robinson, Director of Automation at Mechoshade, and one of our valuable member companies. David has actually been involved in EnOcean longer than most of us. He was part of Zumtobel in 2003 and did projects with EnOcean, for example, Cadbury's in UK. So he knows EnOcean longer than most of us, and he's now working at Mechoshade and will show us the solution they have and some of the nice case studies they have. This webinar is being recorded. We will give the link to everybody afterwards. And if you have any questions, please feel free to type them in. And at the end, we should have time for a couple of questions. So again, to the opportunity, this isn't new to most of us, but of course, I like to reinforce this, that today we have somewhere between 10 and 20 billion sensors in the world, and over the next 10 years, it's going to go up to somewhere around 100 billion. Now, a lot of them will be battery operated, a lot of them will have a cable going to them, but a significant number of these will have to be energy harvesting powered. We cannot pull a cable everywhere, we cannot change batteries everywhere, it's just not possible. So even if this number is only 10 or 20%, it's still a huge opportunity. We're talking about billions. And of course, we are the clear leader in energy harvesting wireless sensors with our 20 years of experience, thriving ecosystem, open standard, number of members and products. So we are in an excellent position to service this market. And also very encouraging for us is that we are now seeing other organizations such as Matter, CSA, formerly Zigbee, Bluetooth, and others also putting energy harvesting wireless on their roadmap or even starting to write and release specifications for this. This will give us a huge tailwind because we have the products, we have the solutions, we have the experience. And this will give us a huge tailwind. The other opportunity, very high level, of course, everybody is talking about saving energy and CO2 reduction and going CO2 neutral at some point of time in the future. Corporations have CO2 neutral goals, governments have commitments, governments have legislation. And of course, to make buildings energy reduced and CO2 reduced, you need to have sensors and switches. You need to have some form of automation. This is a huge opportunity for us. Buildings use 40% of our energy and 36% of our CO2 output. To reduce all of this, you need our sensors, you need automation. The other one which is up and coming is what we call health and wellness. Maybe some of you have heard of ESG, which a lot of corporations are also now highlighting. And one of the pillars there obviously includes energy and CO2 reduction. Another one is about health and wellness. This has become more important through COVID and through people's awareness of air quality, CO2, etc. So again, a huge opportunity for our sensors and switches to measure this, to give the data to all of these systems. And also we're seeing on-demand sharing society, desk sharing, hybrid working, and people are now wanting to collect all of this data. So we have a huge opportunity for our energy harvesting sensors and switches and a huge tailwind. I want to highlight today one example of legislation which gives us a huge backing and tailwind. This one was published in February of this year by the NFPA in USA. This is basically the National Electricians Code. So if you're installing any electrical stuff in your buildings, each state usually adopts this code, and you have to keep to this code, otherwise you could be liable. Or if you're selling your house and you don't keep to the code, you could have issues. And the new one that came out this February clearly states, and I've quoted from this, that the switch or wall-mounted control device shall not rely exclusively on a battery, unless a means is provided for automatically energizing the lighting outlets upon battery failures. That basically means you cannot just sell a battery-operated light switch on its own anymore and be code compliant. Our energy harvesting light switches are code compliant. So this is a new huge opportunity, which I don't believe is widespread known yet. But just going into Home Depot or getting your electrician to install a battery operated light switch in your home is no longer code compliant. So again, this is helping us, this is giving us tailwind and giving us, especially in this case, a huge new opportunity in USA. There are many, many examples of legislations. We have in Germany, Gebäudeenergiegesetz, we have in Europe, the EFPD, PBD coming in, and just about every country in the world are putting out building codes, which goes more and more into needing sensors and switches to provide data to manage and control your building. Smart spaces is the new pillar that we're building on with partners such as Aruba, Microsoft, IBM, and others. Traditionally, our sensors and switches are being used for smart homes, smart buildings very successfully. And this is a new opportunity that we've been working on for the past 2 or 3 years, collecting data from your building using the existing access points in the building. So in this example, if you have a school, a hospital, an office, or whatever with an Aruba network, you simply put an EnOcean USB receiver into the access point, and you stick the sensors and switches wherever you want, and you start collecting the data. And this is very powerful because you can go into an existing building, there's no pulling cables, there's no mess or noise, there's no redecorating, and you can get the data you need from your building so you can then optimize it. And very quickly, the key use cases we're seeing of that is office space optimization. With hybrid working, we're seeing most companies have up to 40% desks unused at any one time. That's a lot of space, that's a lot of money. One desk in a major city costs $10,000 per year. So if you have hundreds or thousands of unused desks, this is a huge cost. So companies want to know this and they want to optimize this. Another very popular one, especially in Far East, is digital restroom management, cleaning on demand. What is the usage of the restrooms? When do they need to be cleaned, etc. A third one is what we call health and wellness, employee productivity. When an employee is in a perfect environment, good air quality, good lighting, noise levels, etc., temperature, humidity, then the employee is healthier and is 15% more productive and 15% less absent. People counting is another one. How many people are in a room or an area? How many people are in a conference room? How many people are in the canteen, whatever? Again, to use the data to optimize your building's use, energy, and costs. And most of these all come back to energy monitoring and savings. And typically in a commercial environment, you can save 30% energy and CO2. So this is significant. And as I say, a lot of this without pulling cables, without disrupting your building. So summarizing the benefits for the users of using EnOcean sensors and switches in their system, savings in installation time and cost, in retrofit scenario up to 80%, in new builds up to 15%. The users are seeing improvement health and wellness of the employees, motivation, productivity. Space optimization is a big one, conference room, right down to desk level, restrooms, canteens, etc. And as I say, going back to the energy and CO2 savings that everybody is aiming for, we're seeing typically 30% in commercial environment. And of course, all sustainable, maintenance-free for decades, no need to change batteries, no need to pull cables in many cases. So all in all, a huge opportunity for us. And we as an alliance are growing. The deployments of the technology are growing every year. And we expect to see this trend continuing. But I'd like to just finish by saying a few words to who we are and then pass over to the main part today, which is David, showing real implementations of the technology and real case studies. So yes, we are 400 member companies, 5,000 different products, over 20 million products installed, and an international open standard. We are the leaders in energy harvesting wireless by far. And for those of you who are not in the Alliance yet, again, the key things we do in the Alliance, we create the technical specifications to enable you to get faster to market with multi-vendor interoperability. We have a networking platform where we network in the ecosystem. And of course, we spend a lot of our time on marketing and education of our technology and of our partners and members' solutions. Here's an overview of our main members. We have 400 member companies. We've already welcomed about 15 new members this year, and we continue to be a thriving ecosystem. So I'd like to pass over now to our keynote speaker today, David, who will show us some real-life case studies and solutions with the technology. Over to you, David. Thank you.
Thanks, Graham. I just want to confirm that you can see my screen.
Dita, can you confirm, please?
Yes.
Yep. Okay.
So you can see the presentation.
Yes.
Okay, let me start. Great. Well, Graham, thanks very much for the opportunity. I think I want to just try and squeeze in to the next 15 minutes, a 45 to 50 minute presentation. So I'm going to do it from a 40,000 foot perspective. Automated shading is fairly well known within the US, not that well known in other parts of the country, but we tend, in other parts of the world, we tend to try and deploy shades to, in essence, assist everything that Graham highlighted in terms of what are we doing for the built envelope. We're trying to enhance the space that people are being put into, because in this new post-COVID hybrid environment that we find ourselves, we have to really make sure that occupants are comfortable in the space that they are being subjected to during the course of their working time. And you really want to make sure that you manage the space both from a visual perspective and also from a thermal perspective. So those of you that are designers, the ultimate goal is to have this building as shown in this image in terms of how you can portray this to your client in terms of this is the way the external facade is going to appear. Unfortunately, without automation, this is very rarely the case. Manual shades tend to create what we call a sawtooth appearance, whereby shades are left in all different positions, and a manual shade, in essence, is only correct once a day, and that is the time that the person who is sitting adjacent to that shade moves that shade for their individual thermal comfort. So we want to make sure that we have got a basis on how we can actually manage the shades during the course of the day. The way in which we do this is through an automation program called SolarTrack, which is our daylight management platform, whereby you take the real climatic conditions which are being measured during the course of the day, and you ultimately deploy them and allow the system to actually manage the position of the shades to that optimal position. And with this being said, you ultimately need a system which is adaptive, it's dynamic, it's responsive to what is happening outside the building, but ultimately it's automated. You don't want to have too much human intervention in the way in which the shades are actually managed during the course of the day. So to facilitate this, we typically use roof-mounted sensors, but in today's world where we're doing a lot of retrofit work or a lot of TI work, tenant improvement work, we haven't always got access to the roof. So what we have to do is we have to deploy different technology, and that's where EnOcean comes into it, because we very rarely want to run additional cabling to connect sensors to our networks, and we have found a unique solution in the way in which we can actually manage the harvesting of daylight levels, of potential overrides, which are from keypads, or from occupancy devices, whereby shades may not have to be deployed or may not have to be raised if the space is not occupied. So we tend to tier our automation depending on the level of automation required and actually the size of the installation. So a typical application of how we would deploy this in a very small environment, typically a floor or a couple of rooms within a space, we use typically 3 different EnOcean empowered devices. We've got keypads. We also use the paddle switch, which is solely kinetically driven. We also use a daylight sensor, which has got multiple elements that it can actually realize, and these all communicate wirelessly through EnOcean technology to a receiver, which we have centrally located, and we put it on our network. So we then also have the ability to incorporate occupancy sensors. So if the space is not occupied, you don't need to have the shades raised, or depending on the time of year, you may want them raised to actually harvest that thermal energy to actually work with the HVA system in that space. So it tends to be fairly dynamic in terms of how shades are managed based on what all these sensors are actually capturing during the course of the day. Our base program in terms of our SolarTrack tends to, as I said, use roof-mounted devices where we actually gather the microclimatic conditions above a building. We then manage the position of the shade based on a number of criteria, either solar penetration, we call it. In other words, how much direct solar do you want to allow into a space at any given time? Or we can actually manage the position of the shade through thermally moving or thermally managing the radiation on that elevation and positioning the shade to actually intersect that thermal energy and position it to the most appropriate position based on the requirement of the end user. However, as I said, we don't always have access to the roof. So how are we going to manage the position of the shades if we can't actually gather that microclimatic condition above the building? That's where we tend to use internet weather, which is an API which is readily accessible for anybody in the world. It's a weather open API, and unfortunately, it's only as good as the weather which you potentially see on your phone when you look at it. Quite often you will see the weather feed from a local station. It'll say it's going to be clear and it may be cloudy. So the way in which we have to validate this is through the deployment of sensors, and we have a minimal number of sensors that are deployed. But due to issues that we've seen in the past with regards to battery-operated sensors or wired sensors, we knew we had to explore a technology which would facilitate almost a install and forget scenario. That's where we came up with the concept of including the EnOcean technology in our sensor. It actually has a little photovoltaic cell on it, so it constantly charges from the sun and actually transmits data to our system, which facilitates a real-time recognition of what is going on. I'm not going to illustrate every one of our types of solutions. What I'm just deploying here is a lot of you, I don't know how many of you are familiar with PoE technology, which is power over Ethernet. We're seeing an accelerated demand for this technology, but hand in hand is how can we capture data to facilitate the deployment of this technology in not only shade automation, but also in lighting automation. So we utilize the EnOcean technology to gather a lot of data with regards to how we can control shades based on automation algorithms. And as I said, those are either daylight levels, occupancy levels, or human intervention in terms of overrides. How are people managing those shades? How do they like them positioned if they are in a meeting room and they want to deploy them? We can then incorporate that, build it into strategies as to how those shades are managed during the course of the day. We've actually taken it one step further, whereby we have taken EnOcean technology and actually incorporated it into the head of our motor. So with a certain range of our motors, we don't actually need auxiliary receivers anymore. We can actually speak directly to the head of the motor, and we can create multiple endpoints that can speak to an array of different motors to make sure that you're always getting the most accurate, up-to-date information from daylight levels, from occupancy levels, or from switch overrides. And these are really coming to their own in terms of how we are deploying, because it just makes the overall installation simpler, less wiring, less cost. And these all aid to the installation cost, reducing the installation cost, but at the same time, actually aiding the way in which building costs are reduced, your labor cost is reduced, and ultimately all your infrastructure costs are reduced, because you're now transferring a lot of that information wirelessly, utilizing the EnOcean side of things. This is just a simple deployment. This is one of our deployment drawings which we give out to some of our specifiers, just to show the array of different wireless opportunities we do have, because quite often people want to know what our system is capable of doing in terms of how it can actually interact with different devices. And so this really goes to show how we can interface with our receivers, interface with some of our motor heads, and ultimately control the space. This has led to a number of really successful deployments across the country. On our shade automation side, I can tell you now that every single one of our automation shade deployments utilizes EnOcean technology, because we deploy sensors on every one of them just for validation of what the radiometers are gathering at any given time above the building, which is the devices we use to actually monitor the sky conditions. But then also, if we are using internet weather, it's to validate the response from that. Cisco was a unique opportunity insofar as it's a single floor in a building in the center of New York in PENN 1, and they couldn't get access to the roof of the building for this particular location. And we had to aid them in terms of achieving their corporate goals as to how they wanted to manage that space. And it is really something which has worked out well. And we've utilized sensors insofar as the entire space it's probably got, I think it's got about 12 sensors across the entire floor, just over 50,000 square feet. And it has become the pinnacle in terms of how those shades are managed during the course of the day. And it has really given us the capability to interact with other systems in terms of the shading. The shading system interacts with lighting, with HVAC side of it, and there's a plethora of different sensors that has really allowed us to enhance the performance of that space so that people can be drawn back to the work environment. In today's world, we have to make sure, as I said, we have to make sure that we're making the space as comfortable as possible in this new return to work environment that we are faced with. Cisco actually have created an online 3D tour of their space where you can actually go in and walk around the space, do a complete 3D tour. And in that, we've actually got various callouts just to show people how the technology has been utilized in terms of how we are gathering internet weather, how we are validating that internet weather through this array of EnOcean enabled sensors strategically placed around the elevation of the building, just to make sure that we can position the shades in the optimal position during the course of the day. We've just recently completed the Cisco Atlanta facility, which is considerably larger than the New York facility. And again, the strategic goals, this is Cisco's policy to actually deploy these on every one of their retrofits that has been deployed across the globe at the moment. And we are working on another number of locations where we are actually assisting the way in which shade automation can work hand in hand with lighting, work hand in hand with the HVAC, but also with regards to how shades are positioned to ensure visual comfort for those in the space, that they can conduct a semi-virtual environment when they're in that space. And this it's really been borne out with regards to how shades are positioned during the course of the day, giving those people comfort in that space, giving them thermal comfort, visual comfort, and ultimately aiding to the way in which energy is being saved. Another quick case study with regards to where we've had a really successful deployment was with NetApp in Wichita, and this was an innovation campus, and we wanted to make sure that we could again create that visual and thermal comfort during the course of the day. Sensors work in tandem with our roof-mounted radiometers and have really proven to be the winning solution for the comfort of the people within the NetApp environment. So with that being a quick 40,000 foot view, I just want to say thank you for the opportunity to actually educate you on what we are doing with wireless technology. And we believe that wireless technology is key in the fundamental deployment of our shading solutions moving forward.
Great, thank you very much indeed, David. That was very interesting also for me. I have one question. The PENN building in New York, I believe it's a building from the 70s, and very typically for that time period, there's no individual room or floor temperature control, which means the caretaker basically sets the temperature in the morning, and that's it. And if the sun starts coming through the window and people start getting hot, they have to phone him and say, hey, it's getting too hot in here. We talked a lot about benefits for users. What benefits have you seen in that building since you installed this?
Yeah, that's actually a very interesting point. We have seen, and this has been borne out by the people on the floor, with that single pane technology that was deployed in PENN 1 in the 1970s. They were constantly calling the facilities people when they were adjacent to a window wall and the sun came in. They deployed the shading system, and since then they've actually started replacing the glazing with new triple pane glazing. But the one thing which stuck in my mind on one of the tours that we did was that since the deployment of the automated shading system, they've had 0 heat calls. And a heat call is in essence exactly what you described, is when somebody's sitting there and they start getting hot, and the first person they found is the facilities team to say, what can we do? Can you make it any cooler? And unfortunately, they can't within that environment. So, and then interestingly enough, this week they're replacing the southern elevation of the glazing, and they physically removed the shades on the southern elevation through on Monday morning, the first calls that the facilities team got was, it's getting too hot. So it really justifies the deployment of shading, and that is all aided through the sensors that are looking out on those particular elevations, ensuring that the shades are deployed to the optimal positions.
Great. No, very interesting. Thank you very much. Well, yeah, that's it. My big thanks to David for providing us with this very short, compressed overview of the technology and the benefits and some real case studies. Thank you very, very much indeed, David. If anyone's any questions, please feel free to forward them to us per email, and we'll be happy to answer them or give you a call. So again, all thank you very, very much indeed. Our next quarterly webinar is scheduled for December the 7th at the same time. So we hope many of you will join us again then. We'll be sending out the invites in the coming weeks. Thank you all very, very much indeed. I wish you all a great day and a great evening. Thank you very much indeed. Goodbye.
Thank you. Thanks.